Hello everybody, welcome to today's webinar. The topic today is Videogrammetry, how to create a realistic and accurate 3D model from video made with mobile phones. So wow, we have a lot of people joining us today, and the last are still joining, so the number is still going up. As usual, we will just wait a minute or two longer for everyone to join up, and then we will go ahead and start the session. Okay, so I think most of us have joined up. Really big number of attendees today. Welcome again to the webinar. And we will go ahead and start. We'll be talking today about videogrammetry, how to use it to create realistic and accurate 3D models. So maybe just a few words about how we came to start using videogrammetry. So even at the beginning, we were working a lot and trying to add photos recorded with handheld cameras and phones to the model. So quickly we realized that it's quite hard to select good positions for photos when recording photos manually, because you have to move around slightly and you have to think mostly at what you have already recorded and what you haven't, and you have to keep your mind on the overlap, on using correct overlap, and so on. So eventually we came up with an idea to just record a video and let an algorithm decide which frames from video to use. When we started testing this new approach, the results turned out better than expected. So because of that, around February this year, with the last update, we added also Videogrammetry tool to 3D survey. So now let's continue and start the presentation. So first we will look at the timeline today. So as usual, first I will make a general introduction. We will talk a little bit more about why use videogrammetry and how to use it. Then we will have a quick slide about videogrammetry applications. So which fields we think this technique is applicable in. Then we will look at two detailed workflow examples. In one, we will use ground control points to do orientation, and in the second one, we will try to do the orientation without ground control points. So these two examples will be a little bit more detailed. And then we will also look at some other examples that we did, and we will also be looking at what also other options this videogrammetry tool brings us. So in general, we will try, just a second. Okay, so the idea is we explain, okay, just 1 second. So we will show what kind of tools. So we will be learning how to make accurate 3D models with videogrammetry. The goal is to learn what kind of results can be expected and how to achieve these results. And we will be also looking at what kind of accuracy we can expect with this technology. Now let's continue to the next slide with some general introduction. So the challenge today is infrastructure documentation. We tested, so also from the field as land surveyors, one of the general tasks that we do quite often is infrastructure mapping. So this was one of the fields that was quite hard to map with drones accurately. Why? Because we are mapping ditches, we would need to fly quite low, Very often these infrastructure developments are done in cities. Sometimes it's tricky to fly the drone in the city. And so because of that, we were testing how we can create realistic 3D models using phone videos instead of drone photos. So the goal is to have fast and easy data capture mode that will give us realistic 3D models. Now let's have a look at general workflow. So the general workflow in the field will be, we will go out, record video, then we will either do orientation with ground control points, or we will just manually scale and orientate the model. Then we will, as usual, calculate point cloud reconstruction. Then out of that, we'll create a 3D mesh, and finally, we will create orthophoto. Now, I would just like to show with you one video that shows how the field survey works.
Vid, just unmute yourself, please.
So here you can already see my colleague Marco, who's already walking outside, and he's recording a video of this construction site area. So here a new sewage pipe is being constructed. So in order to make a nice video of this one, all you have to do is you take your phone, start recording video, and then you walk up and down along the new construction project. So as usual, everything that's visible in the video will be reconstructed in the 3D model. So this one is great because these kind of objects, they are usually long and wide. So we don't need to record 100 of meters, but the results will be very detailed, as we will see later. Okay, I think the video has finished now. Let's go back to screen like that. Okay. So which are some applications for videogrammetry projects? So the best sites for doing videogrammetry will be construction sites, ideally infrastructure projects like new water sources, water pipes, sewage sites, also for documenting telecommunications cables or electricity works. It can also be useful for measurements of materials, of piles. So if we have some small piles of materials and we'd like to measure them, so for small sites, it might not make sense to set up the drone and fly with the drone or with it. We can also just record video with the phone, walk around the pile of material and make the model this way. So another use case where we see potential is also indoor mapping. We also tested this technology in indoor. Later we will also look at some quick example. With this one, I can tell already it helps if we have good lighting. So the video quality will depend greatly on the lighting. So outside the technology works perfectly. Inside it will help if we turn off the lights. So this technology is also very useful for some quick documentation. So whenever we have some small object that we would like to document or measure later, we can just record a video of it, go into the office, make a 3D model, and then export it, share it with clients, anything like that. Or we can also do some quick measurements on this. And then last but not least, we also have AR applications. So this is still very much in development, but we already see very big potential. So AR here stands for augmented reality. Later I will show you one video example, and we will talk a little bit more about this one as well. So now let's have a look at some tips and tricks for videogrammetry processing. When we start processing videogrammetry, I would just like to give you a few guidelines how to best process this data. So now I will just go to 3D survey. So here I already have a project with videogrammetry that was calculated. So if you want to process videos in 3D survey, the workflow will be following. We will go here to images, and we will use this one, extract images from video. So here we will now select input file. So this will be one video.
Just share the correct screen.
Okay, just 1 second. Like that.
Perfect.
Okay, here is now our video project. Now, to start processing, we will go to images, extract. Okay, just 1 second. Images, extract images from video. Now, here we will select the input file. For example, I have an input here, press open. Project folder will be automatically generated. Now we have here 3 settings. So by default, I recommend you always use this automatic approach. So this approach will automatically select the most appropriate frames from the video. So it will look at the overlap between the frames, and it will also look at sharpness of the video frames, and it will try to select the best ones. So this is the automatic mode. This one actually works the best. The other 2 methods are also the end frame or frame per second mode. So the end frame method, this one just means take every 10th frame, for example. So a video will typically be recorded with 20 frames per second. So 1 minute video will have about 1000 frames, 1000 image frames. So because that would be a lot more than what we need, we could say, okay, take only 1 in 10, and that means we would end up with 120 image frames. Alternatively, we can also just use frame per second. This one is easier to calculate. So if a video is, for example, 60 seconds long, you could say take 3 frames per second, take 3 best frames, and we would end up with 60 images for processing. Pressing OK would start processing now and selecting the video frames. So we will now just press close, and now we'll have a look at this project. So this is our construction site that we did. So here I just had my phone upside, so that's not a problem. We get this kind of upside images. And if we look at them real quickly, we see that I just walked along this water pipe construction project. So also we printed some small 3D survey ground control point targets on paper, and we placed them on the ground. So we measured these points with a handheld GPS device to make this data accurate. So, and here we see how we walked along this construction site. So these are already the extracted video frames. Okay, then as far as processing is concerned, the first step is similar as usual. We go to bundle adjustment. Now, when we go to bundle adjustment, we recommend you to use slightly different parameters here. Because these video frames are smaller, the resolution of these frames is usually 1920 pixels by 1080. Okay, the resolution will depend on camera resolution, so if it's 4K, it will be slightly more than that. But even so, it's less than 20 pixels that we are used to. So because of that, we recommend you to set feature detection level to high. That means more features will be extracted out of each frame. And then secondly, so here, because we have smaller data sets, we actually recommend, so for now, when we have no telemetry information, for pair selection mode, we just recommend you here to set it to all. So whenever you start processing or bundle adjustment, go here to show more, set this one just for this project to high, and pair selection mode to all. Then we would press OK and start processing. Okay, after a bit of processing, sparse point cloud would be constructed. Then, as usual, the next step will be to go to orientation. Orientate with ground control point data. Press next. Here we would then find where we have some ground control points. So actually here we can already see the type points that were automatically extracted. We would mark approximate positions of our ground control points, use this detect GCP targets option, and then just continue to the next step. So here probably the situation will be you will have some photos from very close by, some will be from further away. So probably here there will be some manual adjusting of these positions. So here it's only important to have each ground control point on, say, between 5 and 10 images. That should be plenty. So this is approximately what I did here. And then you would just press next, and then this data would be added to our 3D model. So up to this point, the workflow was completely the same as is with the regular photogrammetric approach. So let's just wait for this orientation to now continue for a bit. And we would get results as usual, the ground control point errors, and then we can just simply press finish. And now our model will be georeferenced. Now, as usual, the next step will be reconstruction. So again, we will select reconstruction level. Now, one important thing to note, so the images here only have 2 megapixels instead of 20 megapixels that we are used to. So because of that, this dataset that has now some 750 images, this one should probably calculate in about, it should calculate about 10 times faster than it would if we had 20 megapixel images. So with the GPU support, probably would be, here we would be looking at under 1 hour of processing on high. So this is another great benefit because we are using this kind of data. The processing is significantly faster. So even 3/4 of an hour would be too long to wait now. So we will just press cancel here, and we will continue straight to point cloud to check what kind of results we can expect from this technology. So this is already our point cloud. If we zoom in on it, let me increase slightly the point render size. So interesting now, because we are using close range photogrammetry, because the images were recorded from quite close by, then all the markings that are made on the terrain, they can be easily visible. Also, if we zoom in here on some details, even here in the point cloud, now all the details about how the pipes are going, where they intersect, this will all be very clearly visible. So we can see ideally where the pipes intersect, and we can check exactly for the details. Now from this data, we would create a new full 3D mesh, and we have already calculated it. So I can just go to mesh. I just wait for a while for the mesh to load and see it in here already. So this gives us considerable advantage over the regular survey techniques, where we would just measure here a few total station points and connect them with the line. So from this data, we can see exactly what kind of pipe is joining the other one. And here we have this second one, how thick is this one? Now, for the most important question, what kind of accuracy can we expect here? So for this purpose, we will go to data, load cat. So here over this area, we also measured some checkpoints with the GPS, and we will now load this in here to check the accuracy of these results. I'll just press import. And actually here we already have some points measured. So we measured 3 points in this location, and we measured some more points here. So these were the points measured with the GPS. So I can tell you exactly. We will now go to measure distance, and we want to display 2D distance and delta height. Let's make our measurements, for example, bright red. And we will be snapping to try like that. So if we check here, so this was the point we measured with a GPS. And in this example, right about here, the intersection was the point that I measured with our GPS device. So in this example here, the accuracy was in range of a few centimeters. So this is what we would be expecting. So if I zoom in slightly more here, and check this one as well. So this one probably was measured just about somewhere here. So here we now see an accuracy. Definitely we have an accuracy better than 10 centimeters. But probably, you know, for this kind of construction projects with this kind of detail, even 10 centimeter accuracy would be plenty. So if we imagine that sometime in the future, these pipes will need to be excavated. So if we have this kind of data, from this kind of data, not only that we have here 3D position, we could also measure exactly how far from the edge of the road our pipes are. Of course, the road can also move, but here you see we have, we take wide amount of data, and later we would be also able to put this data out in the field and compare it to the situation that maybe we will have in about 2 years from now. But in short, the accuracy we can expect from this kind of data, if we use some ground control points, we can expect better than 10 centimeter accuracy. So in our case here, probably the accuracy was better than 5 centimeters. But of course, the accuracy will depend on each project. Okay, so for this first example, so here we showed how we can orientate this model with when we have ground control points. Now, yes.
Thank you for this part. Super interesting presentation, how it works, what kind of results can we achieve. A number of interesting questions we also get in the chat box. I would just like to remind you all, please write your questions during the webinar in the question box, and then we can answer them. So don't forget it. So write them immediately, and we will answer them during the webinar, then at the end of the webinar. And we also have a short poll for you with questions. Just to get a bit of feedback from your side, and maybe this is a good time before we go to the next presentation to launch first 2 questions for you.
Okay.
So if we are ready, I can launch my first question. So this is which industry do you work in? You should see the question on the screen. The first answer is surveying, second construction, architecture, public safety, and other. So please set your answers. I see more than 60% already voted for this first question. Let's wait a couple of more seconds. Okay, more than 70% voted, so I think I can close the poll and also share the results with you. So we see here that we have a bit less than 80% of surveying companies, 10% of construction, and 11% of other companies. So thank you for your answers. And let's go to our second question. During Vit is preparing his second presentation. So where did you hear about this webinar? So question set. First answer, social media, web page. Third answer, from colleague, or fourth answer, from newsletter. So it's a great way to get your feedback back to us. So how to promote it, that you can see new interesting webinars are coming, that you can register and learn new things. Okay, 75% of you already voted. Let's wait a couple more seconds. And 3, 2, 1. Let's close the poll and share results with you. So as we can see, 25% from social media, 21% from web page, 4% from colleagues, and 50% from newsletter. Okay, cool. Thank you for this. This was a first part of quick poll. We have 2 more questions before end of the webinar, but let's wait till that. Again, please set your questions in the chat box if there are some that we can answer them and that. Okay, and yes, Vit, please feel free to continue.
Okay, I think now you can just, okay, perfect. So, okay, now let's have a look at this second example. So for this second example, this was actually happening in our offices. So we had some small construction going on. We had a leaky pipe problem. And so construction guys came and they were searching for pipes. And when they were doing the digging, I quickly went out and I took some videos of it. So now for this one, I actually recorded 3 separate videos. First, I processed each one separately, but then in the end, I just joined the images from all 3 and I just processed them together. So maybe, so I quickly checked the questions and I saw that there was a question about the size of the videos. So these videos will typically be about 100 megabytes or something like that. So if we quickly look at the video, how it looks like. So here the camera was in landscape mode and I just walked along, record the pictures nice and slowly. And you know, you have to watch out so that you don't trip over when you're walking around the construction site. So we're now thinking of 2 things, recording video and not tripping over. So this video is maybe 40 seconds long, something like that. Went twice around the area. Okay, wanted to get this side also a little bit. So you see, it's just a regular video. It's not really that you need any kind of video skills. Then I made a second one, you know, just to be sure that I will get a nice result. And I went around this pile of material here. Stepped over the pile, trying not to disturb it too much so that it wouldn't move. Mostly paying attention where I step. And then this was the second video. And similarly, I also recorded video number 3. Okay, so this one. The third one was very simple, was very similar, so I'll just go quickly through it. So for each of these, I made one model, but in the end, of course, I got the best results where I just joined the photos from all of this into one project. And this is what we are seeing here. So here, the workflow was again standard workflow, except this time I skipped orientation. So first, I performed bundle adjustment, select here to pair selection mode to all, go OK. So we only had 200 images with very small resolution, so the processing was quite fast, maybe 10-15 minutes. And then after I got results of bundle adjustment, I got a sparse cloud that is not orientated. And then I just went from this point straight into reconstruction. On high, so this one only calculated about 15 minutes or so. And then after 15 minutes of processing, we got this point cloud. Again, because we haven't provided any georeferencing yet, the data is not yet georeferenced, nor is it scaled or correctly orientated. And again, then on unoriented point cloud, I also created a mesh. So this is also the textured mesh for this area. Now on this one, so now we are at a point where I would like to scale it and orientate it. So what I did next, I went out and I measured. So I tried finding a good distance to measure with a measuring tape. So I decided to measure the distance between here, the edge of the facade, exactly on the edge, and the point directly on the ground, like that. And I just measured the 3D distance between these 2 points. So this came to 1 meter 8 centimeters. Now what I will do, I will measure this same distance in our unscaled model. So I'll go here into CAD, measuring tape, make the size of the measurement slightly bigger, and we're interested in 3D distance now. So now maybe let's just zoom it a little bit better. So here, useful technique is to do it like that. Just double click here, and this will allow us to zoom better here. Now we'll use our measuring tool. Click here, and we will just be measuring on the surface, so on the mesh, so like that, and measure to this point here, exactly. So just like that, I measure the same way, diagonally. So we have here, for now we have here 53 centimeters. I'll just use calculator. So my measurement was 108 centimeters divided by 53 centimeters. That gives me a scale ratio of this much. Okay. For now, we'll hide this one. Go into mesh. And now we will use this transform tool on the mesh to approximately orientate and scale our model. So right click here, press transform. So here now we have this new transform tool that was also added with a new version of 3D Survey. So there are two ways of how we can now transform this data. We can right click on the edge and we can rotate it like that. So we can rotate it around these edges. So actually the best way to do it, I'll just press cancel and I will start again. The best way to do it actually is to first orientate your model. So here the blue line is always pointing upwards. The red one is pointing towards east and the green one is pointing north. So we point it like that so that the blue is pointing up. Now I'll just go here and I will change the omega so that our model will be approximately so that it will line up approximately with our vertical wall. So okay, maybe turn it like that. So I'll move it here. Oh, a little bit too much. Okay, and then we will also change kappa so that it lines up also in this direction. You could also change this one and make it like that. Let's move it slightly. I want to make sure that the terrain is flat. Like that. I think this will work. And now for scale factor, we will just use the value that we calculated here. So 3.037. So just enter it here. 2.0.377, for example, like that. Press confirm. Okay, first thing I will do, I will delete this this one and go back to mesh. And now our model is georeferenced like that. So like that, first we georeference our model. And now when the model is rotated correctly and scaled correctly, what we can do now, we can create the orthophoto. So we go to orthophoto, calculate new top-down. For example, because this was recorded with very high detail, I can, for example, set 1 millimeter resolution and press calculate. So this will just take maybe 10 seconds or so. And we also get the orthophoto. So here actually we can see the thickness of the facade in our orthophoto, for example, and here we can see where we have. So I think these are the electricity cables, and here is the water pipe going into our offices. Okay, so now here you see this. This was the excavated site because we had some water pipe leakage, so the water pipe had to be located. So in our case, they looked at where the water pipe is going into the building, and then they excavated this area. Now with this kind of data, if we would need to find it in future, we could just measure now here. I'll just turn on the point cloud. Now we could just measure and go to CAT measurement. So now it'd be interesting 2D distance and there the height. And we could say from this edge here, go 2.4 meters to the left and 1 meter down. And there will be the pipe coming into the building. Okay, so this was our second example. So here the goal was to just approximately orientate the model when we have no additional telemetry data or no ground control points. Okay, perfect. Now I'd just like to show real quickly 3 additional examples. So here I have a second project that I would like to share with you. So here, so this one we did very quickly without any telemetry data, but there's actually a third way to do it. So in this example, I have here some drone aerial images, and we combined Videogrammetry with drone images. So to do that best, we then recorded some images from top down and some from the side. And if we go to image view, so we flew the drone just regularly, recording regular grid mesh. And then to get best model, we also made some orbital flights. So these images were actually all recorded with just simply the mini DJI mini drone, because this one is quite small and it's easy to fly. And then we added also some orbital flights. And then comes the important part when joining photogrammetry and videogrammetry data. So to get best results, we also went with the drone, got quite low, and recorded some images from the similar perspectives that we then used, that we then recorded the video from. So we went with the drone quite low and also took some quite horizontal shots. And then with the phone, we also recorded some video from this direction. So that then allowed for this data to be joined together quite easily. And this is also, you know, this is the best approach when you're trying to join 2 different cameras. If you can get some images from very similar perspectives, that will guarantee that both of these cameras will be registered together. Now let's go to the point cloud. And here we can see then the joint point cloud. So the goal here was again the construction of this house, and we were interested in having very well defined where the infrastructure works are here on this house. And we ended up getting quite a detailed model. So this data here under the roof, we wouldn't be able to get them from the drone images, but of course with Videogrammetry, this one worked nicely. Okay. Then the example number 4, a question that also comes up quite a lot is how does this technology work with indoor data? So I have here another example. So project open. Okay. So for this another example, we also tested how this technology works indoors. So here, so for this process, I just for this workflow, I just tried to make a 3D model of this garage. So the problem when recording data indoors will be lighting. It's quite hard to get very sharp images. So for this example, to get the best video out of it, it actually helped to use a gimbal stick with the phone. So that helped me to get a little bit better images, even though the images are not very great, because outside we will get very sharp videos, inside because the lighting conditions are slightly lower, we can expect to get less sharp images. So even so, out of this data, we were also able to make some simple 3D models. So here you can see that I kept the doors almost closed. And then out of this data, we again calculated a 3D point cloud of this garage. And also, of course, the full 3D mesh. So all in all, it's quite detailed, but of course the tricky part in here is that you don't have a lot of room to maneuver inside, so you are recording from very close by, and the images might not be as sharp because we are recording them in lower light conditions. Now, for the final example, I would like to show you this one. So for the final example, we tried to model our CEO, Tomasz. So we had him sit as still as possible and took some pictures of him and move around. And we were actually quite surprised with the result that was achieved from this data. So before this kind of before it was quite hard to achieve these results when recording photos, but with video this works a lot better. So we were actually quite surprised that we were able to get this kind of high definition model. So all we did was we moved with the phone around him a few times, and this was the model quality that we got. So we immediately started thinking that this technology also has some potential in medical fields or something like that, because we tried these things also with traditional photogrammetry, maybe even 10 years ago, and we were always struggling to make a very nice 3D models. But with this, with the Grammatry technology, this one actually worked out very nicely. Of course, now we can use this model for printing or for whatever we want. Okay, so now we looked at some examples. Now I would like to go back to my presentation and also talk about a little bit more in detail about what else we are thinking about. So today we saw basically two approaches to use photogrammetry with. So for first approach, we used some ground control points to orient the data. And for second one, we just oriented the data manually so that we were rotating the model so that it would fit some data, and then we have model correctly scaled and positioned. Now, of course, we want to do more than just that. So because of that, we are also now having development a 3D survey scan app. So the idea about this one is to use our own app for recording videos. And the idea is that while we are recording videos, we are also recording the yaw, pitch, roll angles of how the phone is looking when the video is recorded, and that we also take the GPS location. So we actually already have some prototype developed, but I think it will take a little bit longer to complete. And this one allows to also get video telemetry data. So the idea is for fast infrastructure mapping, we want to have that additional data added to the video, and when the video is recorded, 3D survey will pick up this data. So that will mean that in future there won't be the need to manually orientate and scale the data. It should be approximately scaled just from the instruments that the phone have inside of them. So that should give us pretty good relative scale, and if there will be a need for additional, we will also be able to scale the models based on known distance. So that will give us approximate absolute and approximate relative position for our models. Now, this is one way to do it. And the second thing here is also we are now testing some phone add-ons. So these are phone Rtk Gps antennas. So the idea is instead of the 5-meter accuracy GPS that is in every phone, you add this kind of device to the phone, and this one will replace the GPS with more accurate Rtk GPS. So that should then bring the accuracy of the results to maybe around 5 centimeters, something like that. And with this kind of technology, we will basically be getting a handheld scanner. And probably this kind of combination, this is what we are most excited about. Okay, we are getting close to finish. Before we do, I would like to tell you about some tips and tricks for videogrammetry. So when recording videos to use with videogrammetry, first thing to consider is usually what kind of video settings to use. So most importantly here, we were wondering what will we get better results if we use wide angle video or normal angles, because you know normal on the newer phones you can select between wide angle, telephoto and different lenses. So usually the normal angle video camera will have best resolution, but for close range photogrammetry and videogrammetry, also wide angles offer some benefits. And actually in my example, the first example I did with wide angle camera and the second one I did with normal angle camera. Both of these work. I think for inside the wide angle will work better, and for outside you can also try both. On my phone I think I got better results from wide angle camera, but of course that will depend then on the phone, because some other phones will, the wide angle camera on them will be of lesser quality and you might get a better results from normal angles. So here unfortunately I can only say try both of them and see which one works best. Then second, here I would just like to point this one again. For bundle adjustment, use high feature detection level. Use this one because we have smaller images, and that one will find more key points or it will find more feature points on each image frame. And for image matching, so until we have telemetry for the until we have telemetry data for the videos, try to work with all pair selection modes. So that means all frames get matched with all other frames. That will usually give us the best reconstruction. Also, if possible, use Gimbal for inside projects. And also another trick to use is try to, if possible, export camera calibration parameters and use them in future projects. So we actually have a full webinar on camera calibration. If I just show the most important part about it. So here in images, so every time you will calculate a project, you will have some initial parameters and some optimized parameters. So here in this case, actually the initial camera parameters were just calculated out of the focal length data. After the calculation is finished, we got these optimized camera parameters. Then what you would do after you get the optimized camera parameters, you would save this into external file. And then when you start a new project, you would go here to initial camera parameters. They would be like that. You would just press open that same file, and it would update the camera parameters. So here with camera parameters, the focal length is the most important parameter. So we have better value here, more accurate value here, then the calculation will be faster and usually more accurate as well. So although accuracy is not so problematic, because here with video we always record images from different sites, and camera focal length it usually gets calculated quite accurately. Okay, back to the presentation. Okay, these were the tips and tricks. Now there is another thing that we are quite excited about. That's using 3D models from Videogrammetry, so infrastructure models with augmented reality. So the idea is, let me just start the video. Okay, we have some problems with the video starting. And we will do it like that. Okay, so this video doesn't want to start now. It started fine before. I will just quickly start it from directly. So when we are thinking about apps, the first thing we thought, when we have this kind of data, we can create a viewer app for 3D survey where we will be viewing models and then just display the model view on top of camera view. So that will allow us to walk over the terrain and show what is beneath the ground and so on. So we think this is perfect for infrastructure projects because when infrastructure will need to be updated, if we will have this kind of accurate data, we will be able to just take the phone, walk around it, and look at what is under the ground. So we are also pretty exciting about this one, and this thing is also we started developing on. Probably it will still take some time before this one is complete. Okay, let's go back to the presentation. So, okay, now I'd just like to say which are a few advantages that Videogrammetry has over Photogrammetry. I think it turns out so great because with Videogrammetry we have continuous recording, and then later the algorithm decides on its own which frames to use. It's when working out in the field recording video, it's a lot faster than recording photos. You also don't have to think that much on where to record the images from because you just record the video and then you let the algorithm later to decide which frames to extract. This way we achieve better overlap, and it's also a lot more elegant solution. So you were doing photogrammetry before, recording hundreds of videos, every time pressing record button. Now you don't have to push the record button 100 times or more and think about overlap that much any longer. Okay, now for quick conclusion. So in our opinion, now this videogrammetry technique is perfect for documenting infrastructure projects because we usually are interested in data that is it has fine detail. We have long and narrow objects of interest. So these are perfect to record video of. And then in the video, all the important details will be seen. We'll be able to see from the 3D model what kind of, where we have the concrete, where there is no concrete. We'll be exactly able to see where these pipes are going into shafts and so on. We can see what kind of insulation we have on our pipes and so on. This technique will also eliminate missing data. So we know that when we are mapping things with traditional technique, like with GPS or total station, it can happen that we will miss some important detail and forget to record it. Now with this one, we will get a 3D model, and everything that will be visible in the video or photos will be present in that final 3D model. So This technique can eliminate missing details. As a result, we will get a lot more realistic results because, you know, they say pictures are worth 1,000 words. So I would say results for videogrammetry will be worth even more because we will first have video and then we will also have a model that we can measure on. And hopefully, as we said before, in future we can use that one with additional AR or something like that. It's also quite fast and elegant method. Even the technology here that we used when we were using ground control points for mapping, this one was quite fast because we only had to record 8 ground control points with the GPS and then just record the video. But if we can in future eliminate the need to record the ground control points, then the technology will be especially fast and especially elegant. It gives us new opportunity to realistically document some small sites. So if we have anything small that we want to document, what it is, how it is now, this tool should give us a very good option to do that. And the data can be combined between drone photos and videogrammetry photos or handheld images to get the combined model, which will improve the model details. And of course, there are also lots of new opportunities with augmented reality. This one will also be a very interesting one. Okay, so this was the presentation. At this point, I would like to, before we go to the question box, anyone, so here if we have any new users, just like to bring your attention to our webpage. If you want to try out Videogrammetry, you can just go here to our webpage, and here you will see this free trial right on the top of the webpage.
Change the screen, just change. Oh, perfect, perfect. Now we see.
Thank you, Marco. And here, just press this one, get your free trial, and test it out for yourself. Now, at this point, my colleague Marco also has a poll with 2 additional questions prepared. So Marco, can you now go ahead and start the poll?
Sure. Now, before we start with the pool, number of interesting questions are in chat box. So in the meantime, maybe you can check them and prepare yourself for answering. I try to answer some of them also during the webinar, but sometimes it's easier to explain them, and they're super interested. So questions and answers came after the pool. And now we prepared 2 questions for you. And the first one is actually, have you tried Videogrammetry yet? Simple answer, yes and no. So if you ever tried out, we released this functionality in February, so it's already 2 months available. Maybe you did already some tests, get some results, and we are super interested if you tried. Okay, more than 60% of you already voted. Couple of more seconds. Okay, let's say we can close the pool now, and we have results here. So 26% of you already tried Videogrammetry and 74% not yet. Hopefully you learned something new today and you will be confident enough to try out this feature of 3D survey in the next project or in the next application where you actually see the potential. And then another question which is coming up, this is more for the users who are not already 3D survey customers. Are you in the process of acquiring photogrammetry, videogrammetry? So it means if you still not have the software, Are you deciding to buy the software and start to work with photogrammetry or videogrammetry? Simple answers, yes, no, and blockbuster answer, send me an offer with 5% discount. So we prepare some special promotion for all webinar attendees of this webinar, that they can get some additional discount for the license or for subscription. Again, more than 60% already answer it. Couple of more seconds, and let's close the pool. And here are the results. So yes, 36%, no, 52%, and send me an offer, 12%. So thank you for your answers. That's all from questions for pool today. And Vit, feel free to continue with the questions.
Thank you, Marco. So, wow, I see we really have some interesting questions today. So quite a lot of them actually. So before I go and start answering them, I would just like to say if anyone else has a question, there's still perfectly enough time to write it in the question box. And now I would just like to start from the top. So Mr. Sutter is asking, I assume this also works with normal handheld cameras, no cell phones. Yes, it works just the same with handheld cameras. If you try to use it, try to use both. Could be that your more expensive handheld camera will not produce as nice result as the phone will. So I'm not sure exactly why, but the phones, they now make very good videos. They are very well optimized. So we also tried making some videos, and we asked a colleague to come with a very big camera that he's using for photo shooting and stuff like that. And the results from that camera were not significantly better than the one from the simple phone. So, okay, even there will be differences between some phones, but for now, we see no reason to use handheld camera instead of phone, but of course, both of these will work. 3D survey takes as input video, and that's it. So there is no need to, it's not tied in any way to any specific product. Second question is from Mr. Nunez. He is asking, do you think using a manual gimbal to hold phone will make videogrammetry more accurate with no ground control points? Yes, I think that will help, but it will mostly help indoors. That's what I found, because indoors, when you're recording phone, you are not holding it as steady as gimbal would. And in low light conditions, we will get better quality data if we use handheld gimbal. Outside, I didn't see much need for gimbal. So when recording with gimbal, then the orientation and everything will be controlled by sticks on the gimbal. Outside, it was easier for me just to hold the phone and rotate it really slowly. Okay, Mr. Hussein is asking, can you please let me know which application is used for the whole process? Okay, maybe this one was not clear enough. So this whole process was done in 3D survey. So, okay, the video itself, it was recorded on phone, so it can be recorded on an Android or on iPhone device. It can also be recorded on handheld camera. This doesn't matter. But then once we get the video, we go into 3D survey. We go to images, extract images from video, and then we just continue with the process. So the whole process from recording video onward to orientation, everything is done in 3D survey then. So at the beginning, I was trying to show you how this works, and well, I have a new setup. So a part of the video was not showing up, so I would just like to repeat this step one more time. So I will just go here. I just like to share this one. Now I just changed to another monitor. I just moved my 3D survey to another monitor. Now I'm going, now we select a different computer screen, this one. So now let me check, what do you see? Okay, so when we get the video, we go here to images, extract images from video. This is already in 3D survey. We select the input file, so the input video. We select the extraction mode and press OK. So the video will start extracting frames. We'll get these images, then we'll go to boundary adjustment, orientation and reconstruction, and we will get this kind of results afterwards. So everything is done in 3D survey. Okay, back to our questions. Mr. Jakob is asking, is iPhone compatible? Yes, it is. We also tested it with iPhone. It works. It also works quite nicely because iPhone also makes very nice videos. Geoland is asking, is it possible to combine drone images with video in the same project? Yes. So the workflow should be, you should first extract images from video, and then you put frames extracted from videos and aerial images into one folder. You import all of these images into 3D survey and process them together. Another question from Mr. Nunez. Do you need to try and hold the phone with a consistent elevation, or can I change its elevation to get more accuracy on some detail of construction area? Of course, you can move your phone also to different elevations. This is what I was doing also when I was recording indoors. I was trying to move around, and because it was a small area, I also tried to move up and down as much as possible. So of course, yes, you can also move the phone vertically while you are recording video. Mr. Blache is asking, do I have to turn GPS in the camera on or off during recording of the video file? So for now, it is not yet possible to record video GPS on or off. So we need to make a special application that will record GPS and then write the GPS into the video file. So this one is still in development. When it is developed, the app will probably ask you, will you allow this application to use GPS while you are using it? Mr. Nunez again, do you recommend to go forward and backward when recording? Should I use the same path, or maybe take the path on the right side when going forward and then on left side when going backward when recording video? Definitely, I would recommend this second option. So on the left side of your area, use the left side of your area to go forward, and then the right side of the area to go backward, for example, like we did here. So we went around this area of interest. On one side, we went up. We started here and we went first down. And then we made a circle here, and then we went back up on the other side. Going like that. This will help to get both sides of the ditch, because from one direction you get this view, and from other direction you get this view. Okay, again, showing the wrong computer monitor. Maybe next time it will be simpler if I just use one monitor. That's why I will know what I'm showing. Just one more time. So from one side, you will get this perspective, and you will get this side of the beach, maybe something like that. and from the second one you will get this side. So definitely we recommend going one side up and the other side down along the excavation side. Okay, back to questions. Mr. Bozale is asking which software application is used for georeferenced videos conversation in photos. Yeah, again, and in the beginning, so similar question to before. So 3D survey will extract the video frames from the video and convert them into photos. So no additional software is needed here. Mr. Pitko has set a good question. How far is it appropriate to put the checkpoints apart? So here for areas, I would say I would say up to 50 meters apart, but I would recommend you to use, for example, 8 ground control points for your project. So probably most of your projects will be 200 meters or shorter or something like that. So in that case, I would just place 2 points on the edges. So 2 points on the start and 2 points on finish. And then the rest I would just place at the regular interval between. So then if your area of interest is, for example, larger than 200 meters, then maybe I would use more ground control points. But it shouldn't be necessary to have 50 meters. So having 50 meters between first and second set of points and third and so on, I think 50 meters is plenty. Mr. Kinkel is asking, how do you measure the Gcps data for measurement in 3D project? Okay, in this project, we measured the ground control points using this kind of GPS device. Probably it will be visible in one of the photos. It should be around here somewhere. Here it is. So you can see how we parked it here. So this was the device that was used to measure the ground control points. This is the traditional GPS instrument. Instead of this one, you could also use a total station. If you don't have that one, instead of that, you can just measure a distance on the terrain and just use that one to scale the model. He's also asking, did you measure the Gcps? Yes, with this one we measured the Gcps. Mr. Lee is asking, can you have a how it works workflow video from YouTube or 3D Survey website? Of course, we will also create a video and put it on YouTube and 3D Survey website. Also, this webinar is recorded and the recording will be put on our 3D Survey website. Mr. Bosale is asking, or can you explain how to create georeferenced videos? Yes, when we have an option to create georeferenced videos, we will also create a how to create georeferenced videos as well. Then Mr. Aditya is asking, hello, for video capture using a drone on an object such as a historic building or temple, is there a separate technique for data collection? It is by using the video manually or by using UAV, or is it application that runs the video capture command using UAV? Okay, Mr. Aditya, for you, we can offer you a special webinar here on our webpage. So if you just go to our website, just have to move it down again. like that. If you go here to learn webinars, there are a few nice webinars on that subject as well. I think most interesting for you will be probably one of maybe this one, mapping building facades for 3D representations. And the second one would be this one, preserving cultural heritage with photogrammetry tips and tricks. We go here and you just sign up here for free, and you will be able to watch this webinar, and my colleague here will give some very nice tips and tricks on how to perform these kind of tasks. Okay, back to questions. Mr. Kinkle is asking how many GCPs do you need for a project? So if you're using GCPs, I recommend at least 8 GCPs for project. That should be plenty so that we have more measurements that we need. So 3 measurements would be minimum, 4, 5, 6 would be, in between, 8 would be plenty so that we have more data than needed, so that even if we make some kind of error, we can eliminate that error. Okay. Now, Mr. Nunez is asking again, in the house reconstruction project, when you took some videos with the phone, did you also record the GCPs that were located on the grass?
Maybe I can help you a bit with this one. So what was actually done in this project, we combined drone images with phone images, so with the phone frames, and actually we placed the ground control point targets on the grass, on the road, I think approximately 5 targets, and we use them for orientation, of course, but mostly for the drone images, and then all frames from the phone were orientated with help of the drone images. So actually there is no need that the same ground control point targets are also on the phone images. So the algorithm handles this very nicely, so you don't need to care about this one. If you have ground control points for the drone, then the rest of the frames from the phone are orientated based on drone images and works nicely and also accurate.
Okay, then Mr. Witowski has asked a nice question. He's asking, can you give some tips and good practices for video recording? Distance from object, camera orientation, overlap. Okay, so here the feeling that I got, so here I would say just record with your phone from as high as possible. So you will be probably recording at around 1 meter 80 centimeters distance or something like that. So when you point the phone a little bit forward. So with videogrammetry, it's quite hard to record from higher distance, because then you wouldn't be able to see the picture. So you have to put the phone in front of you, and then I would recommend turn the phone down, or for example 45 degrees forward, something like that, and then you're just moving around. So, and then the things you want to map with higher detail, record those from closer. If you are less interested about detail, you can also record from further away. So, but it will be hard to record things if you record at 45-degree angle. You will be recording from, I don't know, maybe 2.5 meters away. Camera orientation, we try to figure out what works better, landscape or portrait orientation. Both of these work fine. So for some projects we use landscape, for others we use portrait orientation, and both worked well. Now, as for overlaps, I recommend going up and down around the area of interest. and try to record so that you have from two different directions. And as far as overlap is concerned, the software will take care of extracting images with the correct overlap. Ms. Sobochan has posted a question. Great updates, congrats. Thank you, Sasha, good to hear that. Mr. Nunez has asked, do you have any expected time when the scan app will be released? An approximate time would be awesome, just to say we are ready. So hopefully, I would not like to make, whenever we make promises when the new things will be released, we usually say too early. So I would not like to say that. I would not like to promise it right now yet. I tell you that it is in the development. And Marco, what do you think about this one? About approximate time frame. So hopefully, I would say hopefully by the end of this year, the scan app will be released. Maybe it's even sooner, but let's wait and see. So a little bit of it, it's already developed, but we are working quite hard on it right now already. Then Mr. Darman has asked, is this webinar recorded and will it be available for future reference? Yes, of course, the webinar is recorded. It will be available on our website, and also everyone who registered, watched, or just registered for the webinar will also get the recording. Mr. Bosale is asking, can we photo path like Google Street View to do this work? This also shows us where we are going. I think it would be very hard to use Google Street View as input because, when we record photos with camera, we get a single photo. Google Street View is a combination of many photos joined into one 360 sphere. So you can try it, but I'm not sure if you would be able to get a very good data out of it, because those photos, they are actually joined together many different images. So it will be a lot easier to just go outside and get the original photos, or you would have to get the input photos that Street View is using to make, that Google is using to make Street View. Of course, Google would not give you that, so probably this would be quite hard to achieve. Now, Mr. Zalovic is asking, since it is really simple to collect and process such data and everyone has a phone nowadays, do you think it is necessary that the field operator is surveyor, or would you say anyone can do it? Well, I would agree with Mr. Zalovic that anyone can do it, but it's also similar to GPS. Also, the Rtk GPS device is a very simple device, and when it came out, they said everyone will be able to do it, and it is true. But in the end, if land surveyors do survey, then when they need to reopen, redig the site, it's more, usually the data quality will be better. There is less chance the data will be corrupted or incorrect or something like that. So I think anyone can do it, but it will take some practice to get the perfect data out of it. So, okay. Second question from Mr. Zalovic. When should operator choose videogrammetry instead of photogrammetry and vice versa? Based on this, videogrammetry is much more faster and easier to use. Yes, I agree with you as well. So I think videogrammetry will be much faster and easier to use. You can also use photogrammetry instead. It will take you longer to record the images, but the images that you will get will have higher resolution. Now the thing is, the question remains whether you need that kind of high resolution, because when you're if you're recording a facade of a project, so even for that second example that I was showing you, so that was this one. Here we recorded from, I don't know, 2-meter distance. So we had 2 megapixel images. If we had 20 megapixel, even here we had a millimeter scale resolution in the end. So even that was plenty. Of course, you can also work with photogrammetry as before, but it will just take a little more thinking of where to record photos from. Of course, you can also combine the two techniques as well. So you can record some photos and you record video, put all of this into one project and let them process. Even that should be simpler than just doing photogrammetry on its own. Mr. Igic is saying, hi, I am interested once it's done. Are you planning to add simple report? I mean, technical report clients sometimes require documents. Well, so after you do a project in here, you can go project, generate report, generate general project report. You can generate that project. It will give you some report on the project. It will say what kind of accuracy we had on ground control points. But the report that is in this one is very drone photogrammetry orientated. So, but it will also make a report for videogrammetry. Have you now, Mr. Sanson is asking, have you tried with DLSR or drone video in higher resolution, i.e. 4K? Satisfied with the results? Any suggested changes or settings in the software? So actually, we also tried 4K video as well, and it worked just as great as the regular HD video. So probably I would be able to find some projects. I'm sure that for one of the projects I used 4K as well. The results were very similar. So 4K, that actually means 8 megapixel instead of 2 megapixel images. So that then puts it between handheld camera resolution and video resolution. Both of these worked quite fine. Any suggested changes in settings in software? So for me, the most important thing was just to set up camera so that you get enough bright images. So that's it. So with photogrammetry, we usually recommend setting the camera to shutter speed program. For this one, we just maybe set the, yeah, so for indoors, it helped when I set the brightness of the video, if I tried to set the brightness correctly, and I also tried to set color so that the results would look a little bit warmer than they would, because, you know, inside it's a little bit darker and the images tend to be a little bit more gray. Mr. Sefi is asking, what is the success rate of videogrammetry in large areas? Well, for very large areas, I would recommend maybe using drone photogrammetry instead, because there, if we fly, for example, from 80 meters high, we get approximately images that are 80 meters big. And if by large areas you mean maybe 500 or 200 meters, more than 200, then even drone photogrammetry will work very nicely. With video photogrammetry, it will also work, but you just have to keep in mind that you will have to walk up and down the area. So, and with videogrammetry, what we get is a narrow strip when we are measuring. So if you would want to measure maybe 100 by 100 meters area, you would have to make very big videos, because one video frame will maybe cover, I don't know, 4 by 3 meters, while one drone image would cover 80 by 60 meters, for example, or something like that. So I would say it will depend on how you define very large areas, but if the area is truly large, I would maybe use photogrammetry instead. Now, Geolant is asking again, have you tried with GoPro versus mobile phones? Yes, we did. We tried GoPro as well. Mobile phones work better. I like mobile phones video a lot better than GoPro video. Also, it has a lot less distortion to begin with, and I think the quality on these cameras is pretty good now. Okay, also the GoPro that I used was GoPro 4. I don't know which GoPro is now the current one, but maybe the new ones will have better results. Mr. Skotopan is asking, are results better with 4K video? Yes, if we use 4K video, we get a little bit better resolution. So maybe it is a little bit better in terms of resolution. But overall quality is pretty much very similar. Ms. Miletic is asking about processing of data. I didn't hear, is that a regular photo processing is half faster than video? I would say video processing is a lot faster than photo processing, because in video processing we are working with slightly smaller images, but because we are recording our objects from a lot closer, it's okay if we have smaller resolution. It's not really a problem. So I think this is still just okay. Mr. Francisco is asking, Mr. Francisco de Souza is asking, may I see webinar in another time? Yes, of course, you will get the recording for this one as well. Mr. Zimmerman is saying thanks to the team. Thank you for this comment. Mr. Zimmerman, Jakob Jürgen also said best. Thank you. Thank you, Jakob. Mr. Kinkle is asking, what is the best way to measure inside 3D model room? Well, measure inside 3D model room, I would say the best way to measure inside is to use this measure tool once we have the model completed. And I would say it will be best. So here, when you use measure tool, you see you have different snapping options. So this one snaps on point cloud points, on vertices. This one snaps on endpoints. I would say best one to use is this triangle. That means it puts a point on the surface. So that way, if I zoom in to check where exactly we clicked, you see even from far away, it was easy for me to snap it directly onto the edge. And here now it also snapped directly on the ground on the triangular mesh model. And then if it weren't perfect, we could just use this edit tool, select it and say, oh no, I want to move that point here or here instead. Mr. Jürgen is also asking, 360-degree videos are supported. Again, not yet. We were thinking about adding support for 360-degree cameras instead. There are a few things to consider when using 360-degree cameras. Well, you know, because 360-degree cameras will usually have 2 or more lenses and 2 or more sensors. So we are still figuring out whether we should work with one joint image, or if we should look at how we can import the partial images, so the image from camera facing forward, the image of camera facing backward, and then join them together based on that, and make sure that the frame source use the same projection center and so on. So this one, we are already thinking a little bit about it, but we are now very busy with the videogrammetry development, so this one is a little bit on hold now, but we will also look at this one in the future. Mr. Azaga is asking, can you export this 3D data for other software for use for stakeholder, not professional, as 3D PDF file? Okay, 3D PDF file is not supported yet. What is supported is in 3D survey, you can save project, and then your clients, for example, can use 3D survey viewer to just view the project. So you don't have 3D PDF, but you have 3D survey viewer license that you can use for free with 3D survey, so that stakeholder can see the same data that you see and the same measurements and everything. So we think this is better option than 3D PDF. Now, Mr. Pitko is asking also a nice question. Is it possible to orientate an oriented model to control points? This function is actually now coming with the June update. So on June 2nd, 3D Survey 2.16 is coming, and this one will have this option. So, Mr. Pitko, you're just a little bit ahead of time now. Mr. De Souza is asking again, to run this new 3D survey application, we'll need a new special video card like NVIDIA. Yes, so okay, 3D survey will also work if you don't have NVIDIA GPU, but if you have NVIDIA GPU, it will be able to, 3D survey will be able to use CUDA. And all the data that I showed were calculated with CUDA support. So here, so the most important part for that is here in dense point cloud calculation. Here in Reconstruction, you see we have used graphics card. So if you use this one, because GPU is that much faster, that allows us to do more operations, and we get a lot better results. Okay. Mr. Pitko is also saying it's super. Thanks. Thank you, Mr. Pitko. Then Mr. Igic is asking, for example, trench length, depth, simple things. You want to use, I remember before you asked the question if it's possible to make a report on trench length, depth, and simple things like that. Yes, I agree with you that these things would be very interesting to add to report. For now, probably the best way to achieve this kind of report, I would say, would be to go here into mesh and then create measurements. You know, just do it the long way, make measurements. So here, so I'm not like that. Distance is like that. Depth is this much. And then probably, unfortunately, you would have to make screenshots of this and write the report manually. I agree that probably for infrastructure project, we would have to look at which things would be would make sense to add to report and how to make it, and then combine that maybe with some. So we could also then make an orthophoto out of this project, and we have some support for quick reports in orthophoto. You can make orthophoto and make some screenshots in orthophoto and like that. And if you want to more, because we are running a little bit late now, if you write us at support at 3dsurvey.si, we can talk about more about this one. Mr. Ditya is asking, does the DJI Phantom 4 Rtk UAV use video coordinates to read in real time? I think there is also an option to set DJI 4 Rtk. It will actually write the telemetry information in a special file, but that file is slightly tricky to synchronize with the video. So I think maybe that can be done, but with Phantom 4 Rtk, the best approach I would say would be to record some photos. Each photo will have in EXIF the very accurate RTK position, and then even if you add some video next to that one, the photo RTK position will georeference the end result quite nicely. Then Mr. Bossale is saying, thank you for answering my question. Thank you, Bossale, for asking the questions. Mr. Sabolic is asking, do you try with video from drone, low height like record with phone? Yeah, we tried with that one as well. We tried to record the road from asphalt from 3 meters high. Also, the result was very nice. The curves were very nicely visible. So it also works like that. We tried that one, I think, with Phantom for RTK. Miss Miletic is asking again, which are the characteristics of PC of yours which you are processing the data on? So I'm using now I think it's a few years old computer. So we upgraded the memory on it slightly so that I can have always 5 projects open. But it originally had 32 gigabytes of memory. So usually we recommend 16 gigabyte memory for projects up to maybe 1000 images. For videogrammetry, 16 gigabytes is plenty. CPU, well, if you have more cores, it will run better. So this one has a lot of them, but even if any i7 will work fine. And then I have a lot of disks in it because to have a lot of projects. And we recommend you to have a GeForce GPU. So I have GeForce 1070. It's pretty old one. Now it still works perfectly fine. So, so for GPU, you don't need top of the line. So if you have 1070, 1060, 2060, 3060, anything like that will be perfect. We don't. So with GPUs is these last two. The first two numbers tell you how old it is. The second numbers tell you how powerful it is. So with newer ones, 60 or even 50 would be great. Maybe I would recommend 60 because the processing will then be faster. But more, I think, is not very necessary because they are more optimized for gaming than processing. Okay. And a few people said thank you for answers. Thanks a lot. Thanks for joining this webinar and setting the questions. I think this was the session with most questions so far. So this is pretty great. Any additional questions that someone has, or anyone watching recording of this session, if you have any questions, you can always send the questions to the support email and we will get back to you there. Thank you again for everyone to watching this webinar. Again, the recording will go out in an email by tomorrow. Happy 3D surveying. So just one more question that came in right now. Is there a typical guide for proper acquisition videogrammetry? I would say there is no typical guide yet because this technology is so new and everyone is discovering it now. So for now, the guide would be just record video, try to record 2 or 3 videos of the same site and see what kind of results you can get. In the end, you can always just join the images from all videos into one project and try to process them. Probably the results will be better than you expect. Okay. Thank you again for joining this webinar and see you in the next one. Bye-bye.